On November 14, 2023, NASA's Voyager 1 spacecraft suddenly stopped communicating. Instead of its usual telemetry, the probe began transmitting a meaningless, chaotic stream of binary zeros and ones. For 5 agonizing months, scientists were completely in the dark, wondering if humanity's farthest emissary was finally lost to the void. The cause turned out to be corrupted code on a single computer chip. Fixing it required engineers to rewrite and reallocate software on a 1970s onboard computer that holds a total of about 69 kilobytes of memory, less than the size of an average JPEG file. And they had to execute this delicate repair on a machine speeding through space over 15 billion miles away. At that extreme distance, radio waves traveling at the speed of light take 22.5 hours to reach the spacecraft. When the engineers beamed their patch into the dark, they waited almost 2 full days just to hear if the probe understood the command, relying on massive deep space network antennas to catch the unimaginably faint reply. The fact that they were communicating with the probe at all is an engineering marvel. Voyager 1 launched back in 1977. NASA seized on a rare planetary alignment that occurs only once every 175 years, designing a trajectory that would let a single mission visit multiple gas giants. The original plan was entirely focused on our local planetary neighborhood. The mission was slated to last just 4 years, specifically tasked with delivering humanity's first detailed close-up images of Jupiter's massive storms and Saturn's intricate rings. Long after that primary mission ended, the probe kept flying. To conserve the decaying power supply, engineers permanently shut down the cameras, leaving only the instruments designed to measure the surrounding environment, things like magnetic fields, plasma, and charged particles. At the time, astrophysicists assumed these remaining instruments wouldn't find much. The prevailing scientific consensus was that as the probes pushed further from the sun, they would simply drift into a quiet, featureless vacuum. By surviving for decades in the deep dark, Voyager gathered the data required to prove our assumptions about empty space completely wrong. This diagram illustrates our solar system's inner cosmic bubble. The sun constantly projects an enormous stream of charged particles, known as the solar wind, billions of miles outward, engulfing all the planets in a protective shield. For decades, models suggested that this solar wind would gradually exhaust itself. Scientists pictured a smooth transition where the sun's influence simply weakened over distance until it faded out entirely into the interstellar void. But the data presented in this line graph tells a vastly different story. In 2012, Voyager 1 recorded a sudden, sheer cliff drop in solar particles. At the exact same moment, the probe registered a massive vertical spike in galactic cosmic rays hitting it from the outside. The boundary doesn't fade. The solar wind crashes violently head-on into cold interstellar plasma, moving at cosmic speeds. The two forces mix and compress, creating a chaotic, turbulent physical wall. Astrophysicists call this harsh boundary layer the heliopause. It's the definitive edge of our solar system, marking the exact point where the sun's magnetic influence ends and the raw interstellar medium begins. Pushing past this boundary revealed a phenomenon that defied existing models. The density of matter actually increases as you move further away from the sun. The edge of our solar system is a cosmic traffic jam, and that turbulent, shifting barrier is exactly what absorbs the brunt of interstellar radiation, shielding the Earth from deadly high-energy particles rushing in from the rest of the galaxy. We usually think of this deep space environment as perfectly silent. Standard sound waves require physical particles, like air or water, to travel through, meaning they quickly die out in a vacuum. Voyager bypasses that limitation. Its ultra-sensitive antennas are designed to detect electromagnetic plasma waves. When scientists on Earth translated those specific radio frequencies into audio, they heard an eerie, continuous hum sitting steadily at 3 kilohertz. Voyager 1 recorded this exact same frequency humming consistently for almost 3 straight years, maintaining its tone across billions of miles of travel. That constant resonance proves the vacuum outside our solar system is highly dynamic. The supposed emptiness is actually vibrating with energetic waves and magnetic pressure. Scaling out, our solar system is suspended inside a 1,000 light-year wide void called the local bubble. The interior is clear, the outer shell is packed with molecular clouds. 14 million years ago, 15 massive supernovas detonated here, their sheer force carving out this massive cavity. Our sun drifted right into the center of this void about 5 million years ago. By sweeping away the thick, hazardous clouds of interstellar dust, those ancient explosions provided our solar system with a calm, clear environment to travel through. The relatively empty space Voyager is currently exploring only feels empty because a series of violent cosmic detonations cleared a safe harbor for our planet long before humanity even existed. The active exploration of that harbor is rapidly coming to a close. Voyager's decaying nuclear power sources are losing wattage every year. NASA expects to begin a phased shutdown of the remaining instruments by 2025. Within a few years, the probes will completely exhaust the energy required to communicate with Earth. They will witness phenomena we cannot predict, but they will never again be able to transmit those discoveries home. When the power fails, their secondary mission begins. Both spacecraft carry a gold-plated copper phonograph record containing 115 images, greetings in 55 languages, and a selection of Earth's music and natural sounds. It is a highly engineered message in a bottle. Long after the radio transmitters go dark, the Voyagers will transition from active scientific tools into humanity's most enduring monuments. They will continue drifting peacefully at over 38,000 miles per hour, carrying the memory of our pale blue dot into the stars.